Now, in the last topic of the functional concepts, we will delve into the clocks in microcontroller. So you can see that in a microcontroller, there are a number of blocks, peripherals, CPU, memory, and all these blocks have to work in a synchronized way for efficient working. By synchronized way, we mean that let's say when a peripheral transmits or receives some data, so at the same time memory should be updated based upon the transmission or reception, and correspondingly the CPU of a microcontroller should also process the data accordingly, and this whole process should happen in a synchronized way. If the synchronization is not maintained, systems will work abruptly and unexpectedly. Take it in an example where that if our brain doesn't work in synchronous way with our legs, with our hands, then we will not be able to walk, talk, or do anything. So same way, this synchronization to the microcontrollers is being provided by the clock block or a clock functional concept to the microcontrollers. And what does this clock do is it generates the frequencies of digital pulses and fed those frequencies to the corresponding blocks, so that all these blocks work in a synchronized way. And this thing is made possible by the use of oscillators in a clock. Now, oscillators are an internal part of a microcontroller that are used to generate these digital frequency pulses, which is fed to the all the blocks of the microcontroller. And there are two type of oscillators: internal oscillator or an external oscillator. In the case of internal oscillator, in the process of chip designing, the oscillator circuit is designed inside the chip so as to generate and fed the oscillator pulses to the microcontroller blocks. And in the case of external oscillator, we attach some external crystal oscillator to the pins of the microcontroller, and then that crystal oscillator generates pulses, and that is fed to the peripherals or the blocks of the microcontroller from that those oscillator pins. So that's what when I have stated in the pins that there are some reset and the clock pins. So clock pins are used for this external oscillator only. Now oscillators are the clock generators that generate these clock pulses, frequency pulses, that is fed to the different blocks for to work in a synchronized way. Apart from this clock generator, there are two more concepts of phase lock loop and the divider slash prescaler, which are used to either increase the clock of a microcontroller, or and this increase is done by the phase lock loop PLL concept in the clock functional concept. And the divider or prescaler are used to decrease the clock of a microcontroller by dividing them to the certain prescaler values. And after that, these clock generators and these PLL and divider comes the clock destinations, which is that the systems onto which these clock pulses are fed on, like memory, CPU, peripherals, and the system buses, which connects the different blocks with each other. So that's all the things that we need to dwell into the clock functional concept of a microcontroller. So now, as far we have covered the functional block of a microcontroller also, in which we have explored and understand about the pins and the clock concept in microcontrollers. Now in the next video, we are gonna dwell and understand on how to start with any general purpose microcontroller and what is the concept of software development kit and hardware development kit in microcontrollers. And that wraps up this video in our microcontroller technology series. If you're ready to take your microcontroller skills to the next level, don't forget to save this playlist of what is microcontroller technology, as in this playlist over time you will find number of videos which will help you learn about these tips in chronological and interactive way by covering modern day industry level concepts, tools and technologies, so as to become a skilled engineer and not just a graduated one. For viewers who wanted to expand their knowledge by hands-on practical learning, check out our Introduction to Microcontroller Technology course 101, built around the industrial grade NXP S32K144 microcontroller. This course dives deep into peripheral of modern day microcontrollers, teaching you real-world tools and techniques and no more just theory. Head over to edu.gettobyte.com to learn more and get started. Let's keep learning, innovating and building together, because a skilled engineer standouts, not just a graduated one. If you are new here, don't forget to subscribe for more in-depth tutorials and series videos. Hit the bell icon so you don't miss out our next videos, and explore the next video so as to continue your learning in a chronological way from here, and explore the full series playlist linked right here. Got any questions or ideas? Drop them in the comments below. We would love to hear from you.